Because closures in Rust are anonymous when you define them and assign them to a variable, the Rust compiler wants a little bit more from you. I was looking at this and I was like, look at the syntax, and it's not just just a little bit of syntax, it's like just a little bit extra syntax. Just to be able to pass an anonymous function or another function to a function as an input parameter, you have to go a step further. And here's an example, right? We've got a function here that's called apply, and we have to use, through the use of generics, we have to define what kind of, what is this generic, right? We have to type it 3 times. Like this letter F here, and F here. That's so much repetition. And Rust wants you to do this in the compiler because of this reason right here. If you take a look at, say, for example, this closure on line 14, it's a variable that we've assigned to a closure, right? So it's a function, essentially an anonymous function. And there's no type, right? We have not defined any type associated with this. I don't know if you even could do something like this. I don't think something like that would work. It doesn't like it. It doesn't like that either. So it has to be anonymous. Also, it captures data. So one of the best things about closures is that it can capture data and variables in the current scope that it's in, right? The same scope. So you can capture the X variable, and that will get passed down all the way through your apply function. But since there's no type, you have to take one step further and define extra. So you have to define generic F, where F, the variable name F, or I guess we just say this is our function, right? You can say function variable. Function variable is an F, but then we have to also say that F is a function type. And that's mandatory. That's the only way that this can happen due to the Rust compiler during its capturing of the scope. It creates this sort of anonymous structure and assigns it to print, but it holds on to it until it needs to be executed. And at that point, it needs to know what the type is, and that can happen here. So that's where they chose to put it. This is where the type definition occurs. You can also go a step further in simplifying this, or just writing it a little bit differently. Here's, for example, we don't need the where clause. You don't need the where clause, so let's just take that out. And I think you can do something like this, and it works perfectly. Yeah. So you don't need the where clause. The where clause is nice if you're going to have multiple generics in your function definition, but in this case, if it's just a single function, right, you could do something like this, really simple.